Hey everybody. I didn't know if I was going to make this video or not, or even where to jump in to doing this, but I wanted to do this quick experiment to see if this battery pack would actually charge. And by plugging it in, you can see that it is charging. So that is good. So what is this and what am I doing? All right, this is a conversion for the old Milwaukee V18 lithium-ion battery packs. So these are 10 years old, so chances of that actually working pretty low. So I want to see if I can revive the usage of these tools by fixing this battery. So currently there is an adapter. You can adapt this to the newer M18 batteries, but it makes it much larger and I think not as convenient as this. So I was hoping to just basically take this apart and fix it. But unfortunately, these older battery packs use these monster cells. They're Canadian actually made, 26700A cells, but these are obsolete, so they don't make these anymore. The closest you can do is get one that's size similar, so you can, I think there's a 21700 cell, but they're about 30 to 40 bucks each, so 5 of them, $150. So what would be the point of that? So I was hoping that I could be able to take older, or these more common 18650 lithium-ion cells and organize them in a way that they will fit without even making a 3D printed shell to do that, and to see if I could interface with the existing BMS, see if it charges and see if it powers on. So this was an experiment I did. Basically I have 5 cells here in series hooked up. I rewired this BMS, the one that is in this battery, and it looks like the charger is taking a charge. So everything is good. So if you know, if the charging works, then that means I should be able to go ahead and do the extra work to put together the battery pack. So that's what I'll be doing next. So so basically, yeah, if you have dead batteries like this that don't turn on your tools anymore, don't throw out your tools. You can get it working and do it relatively cheaply. There you go. Working. Working again. Okay, so the first step here is to make sure that these batteries are good. These are the ones I'm going to be using. And I'm not exactly sure what the state is, as these are salvage batteries. Actually, all my batteries are salvaged batteries. They came from some new product I got from an auction, so I don't have any reason to believe they're not good. But anyways, I just went ahead and did a full balance charge on these guys with my balance charger, just to see how everything here would react. So it looks good. If we press the button, now we see all 4 LED lights lighting up, which means that this BMS likes these. So these are measuring now at about a little over 4 volts each. So that's good. And if you try to charge it, then you will see this thing goes green. So which means that this guy here will charge these guys up to the right voltage and will stop. I'm not too sure about the current this thing will charge at, but once I stack these things too deep, I think it'll be fine. Anyways, let's put these guys on my other test bench so we can test the capacity and make sure none of the cells are bad. Alright, so I got the batteries hooked up to the test bench. She's reading 20 volts, 20.2, so we're going to use the low power lights and set. So the target set 2.7. Yeah, that's okay. We'll do that. 2.7 per cell. Alright, let's see what this thing goes for. So what's the current now? 3.6 amps. Okay, so 3.6 amps. We'll let this thing run. This thing should be drawing 2 amp hour. So at 3.5, there should be almost a little less than, sorry, a little more than half an hour. So this should be going for about 35, 40 minutes, approximately. So yeah, we'll let it run and see if the cells are bad or if the pack is good. Okay, so these batteries are still going strong. It's almost 40 minutes. The batteries are about 40 degrees Celsius, so they're getting warm. It's been drawing almost 3.5 amps for about 40 minutes and no dead cells. This thing is in great condition. So we'll go ahead and hook up the second set of batteries and see if they're good too. If everything's good, then we'll start making this battery pack. Okay, so I got the second battery pack together. So these are different batteries from a different device, but these are pretty good batteries. I've used them before. I just quickly checked them. It looks like they're all basically around the same. So around 3.9 volts, 3.94, 3.97, 3.97, 3.97. Yeah, 3.97. So these are all pretty good. Pretty close to each other, in fact. So I could use my balance charger, but I want to see maybe if we can just use the Milwaukee charger and give it a charge. So if we press this, it looks like we got 3 bars. It's almost at 4, but we're going to put this in here and let the Milwaukee charger do the work. And let's give that a few hours. I'm not sure how long it'll take, but let's see. Okay, so that shut off after about 2 hours. So it looks like this is a pretty slow charger. Okay, let's see. Yeah, okay, 4 bars. Now, interestingly enough, the light shut off. I thought it would be going green. I guess. Okay, first so it's still on the charger. It just went from red to off. I don't think that's right, but anyways, let's see. Let's see what the voltages are at here. 415, 418, 418, 418, 418. Wow, okay. So this did a nice overcharge. Maybe it's actually balancing. Maybe that's what's happening. I'm not sure. Anyway, but if we unplug this, all right, and then plug this in again, does that go green? Yeah. Okay, that goes green. Okay. Anyways, this is fully charged, 100% charged, balanced, and the light is green. So that's good. Let's put this on the discharger, and we'll see how these ones do. Okay, so this test is concluded. This battery pack is good. In fact, it's really, really good. If I were just to zoom in here on the numbers, I ran this thing at about 3.25 amps on average for 52 minutes, almost 53 minutes, and it did really well. So this is closer to like a 3 amp hour battery pack. Anyways, so I'll put the blue ones in series with the green ones, sorry, in parallel with the green ones. And so I'll start building the battery pack now. All right, so if you take apart the battery pack and you get all that blue fuzz off of it, you'll notice this ribbon cable attached to the BMS, which also attaches to the leads of the batteries. So basically, these are your balance wires. So you can figure out which is which. Just figure out B minus 1, 2, 3, 4, and 5, and then you'll see that you can duplicate this single cell battery pack into these 2 parallel double cells, also 5 in series as well. So the configuration is the tricky part, where I did a little bit of test fitment. I found out that this is the optimum stacking configuration, and no 3D printed shell is required. This will glue together and fit fine. So this is the pattern, and this is the map that you need. All right, so we have our battery packs. So I'm happy with all these batteries. So basically the next step would be to clean these up, and then we can put them into the configuration for welding. Okay, so the fitment of these batteries in this shell is actually almost perfect. As you can see, it fits so nicely between this, and I'll probably have to do a couple minor tweaks, but it fits perfectly. The only problem is it doesn't go to the back here because there's one little thing which is preventing it from going to the back, which is this little thing here. So we're going to grind this away, both sides, and then this thing should fit flush, and the batteries should fit perfectly. Let's see how this goes. All right, Okay, there we go. All right. Nice. It's going to be tight, but should fit. So just to see how good this goes, I'll just start like that. Okay, so that's pretty good. Okay, so I'm done all the connections. Just through a little trial and error, there's a lot of wires sticking up, so I'm just using tape to cover all the contact points. But as you can see here, I got all these balance wires in, B1, B3, B5 on one side, B4, B2 on the other side. Just soldered them in. Main ground, actually when you're soldering it, main ground goes first, then all the balance wires, and then connect positive last. And if you do that in that sequence, then your button should, there it is, the button should work. But yeah, just to make sure you cover all these exposed. I'm still covering some of these things here. And it goes inside the case. It's going to be rubbing a little bit on the shell, so you want to make sure you don't short anything out. And I just did a test fit. Everything looks good, but I think I'm also going to just put some foam pieces. And then this contraption here. So this is a little loose right now, but once it's all in the case, it cinches up pretty tight. So put this guy in first. You're gonna have to flip this around and put that top piece first. And then this piece goes next. There you go. Okay, everything okay. Make sure you've taped out all the exposed metal. Make sure nothing is touching. Okay. Then very carefully slide that into place. Okay, everything nice and snug. Okay, no wires, no tape, dangling. Okay, everything fitting nice, and then put the top on. There you go. Perfect. Perfect. There's a little light on number one because the battery's a little low. Shake it around. Doesn't make any noise. All right, looking good. Put some screws in this. Let's charge it a bit. All right, well, let's give it some time. And we'll try it again. Also, let's try it on the drill and try under load. Make sure our battery is good. All right. Okay, so I gave these batteries a full charge. So now they're showing up as 4 bars. And everything looks okay. So I got a piece of 1-inch stock oak. I'm just going to see if we can power through this with the ratchet driver. But first, let's see if we'll just do a quick counter sink, or sorry, pilot hole. This shouldn't be a problem. All right. Yeah, no problem on that one. Okay, let's see without the pilot. All right. How about lengthwise? Yeah, seems okay. All right. Whew. All right, looks like a success. These batteries are holding up pretty good. All right, cool.